Hello, my name is Ms. Midha, and today we're going to be focusing on the following question. What should we consider when identifying trigonometric transformations? So today there are going to be two tasks for you to work on in this video. Both of them are going to be focusing on this idea of trigonometric transformations. So let's get started. All right, our first task. So in this situation, we are given function p. We're given the graph of function p, and we're also told that function p is given by p of theta is equal to sine 2 theta plus 3. We're also told that function q is a transformation of function p. And we're given information about that transformation right here, right? We're told that there is a vertical translation up by 2. There's no horizontal translation. Vertical scaling is 4, no horizontal scaling. And we're told the order to work with, right? We're going to do the vertical translation first and then the vertical stretch. So using this information above, our task is to sketch the graph of function q and also to write our equation for function q, okay? So what I'm going to ask you to do is go ahead and pause the video for as long as you need and see if you can figure out how to graph this function q as well as write the equation for it. Once you think you have it, go ahead and unpause this video and we will review the answers. All right, so here we go. Now you'll notice that my screen looks a little bit different, but it still has all of the same information from before. It just has a new graph included because we do have to sketch the graph of function q. Okay, so let's get started. So the information about our transformation. Well, the first thing it's telling us is that there is a vertical translation by 2, right? We're going up by 2. So what does that mean? Well, that really means that every point in function p is really just going to be shifted up by 2, right? So I can see here that I have this point at 0, 3, right? That's my midline. That's where it's starting. And I know that this is going to shift up by 2 units. So my midline would start at 0, 5. Right? Same thing here. My max is at 4. That's going to be shifted up to 6. My minimum is at 2. It's going to be shifted up to 4, and so on and so forth. Now, this is going to be hard to sketch right away because there's other stuff we have to look at. So it might be best to actually work with the equation first and figuring out what function q's equation is going to be. So I'm just going to rewrite my function p's equation. So I'll just rewrite it as y is equal to sine 2 theta plus 3, just to remind us. And again, we're working with this vertical translation. So since I'm having a vertical translation that goes up by 2, the number that's going to change in my equation is this 3, right? Because everything is moving up. My midline is really going to be moving up by 2 units. So instead of 3, we're going to go up by 2. So that's going to change to a 5. All right, I'm going to rewrite that. This is not the end. We still have more to do, but I am going to write the first step here. Okay, that's my first transformation, that vertical translation up by 2. Okay, we got that so far. All right, next up, it's saying there is no horizontal translation, so that's pretty great. You can just check that off. And now what it's saying is that there is a vertical scaling of 4. Okay, so let's think about what does that mean, right? What does vertical scaling mean? Well, really, that's like a vertical stretch. And so if there's this vertical stretch of 4, we need to make sure that both sine 2x and 5 are scaled by 4, right? So again, I'm looking at this equation right here. Right now, I know that my first transformation, the vertical translation up by 2, it made us change that 3 to a 5, right? Because we were adding 2. We were moving up 2 units. But now with this vertical stretch, every part of my equation, the sine 2x and the 5, need to be scaled by 4. So the vertical stretch by 4, it's going to multiply the output of the function by 4. So what does that mean? Well, basically, it's going to be multiplying my sine 2 theta by 4 as well as my 5, right? Everything in that output needs to be multiplied by 4. So my new equation is now going to become y is equal to 4 sine 2 theta plus 20. Again, everything in my output, because of the vertical stretch by 4, multiplies the output of the function by 4. Everything in my equation had to be multiplied by 4. All right, so vertical scaling is done. Horizontal scaling, there was none, so that was easy. And then we did definitely go in the correct order. We did our vertical translation first, followed by our vertical stretch. So we have our equation now, right? This is our equation for Q. So now what do we do? Well, now we can go ahead and sketch this function Q. All right, so here we go. I can tell right away that my midline is going to be at 20. And I know that I have an amplitude of 4. So I'm going to just consider the scaling of my y-axis. So let's go by 5s so that we can fit in everything. So this is going to end at 25 up here. And then we can go ahead and start sketching this function. Okay, so my midline's at 20. I'm going to go ahead and draw a horizontal dash line at 20. And I also know that my frequency is 2, right? That number next to the theta is telling me my frequency. So if my frequency is 2, that really means that there are going to be 2 cycles in 2 pi. But it also tells me that my period is going to be, well, let's think about this. This is going to be 2 pi over the frequency, which is 2 here. And that's going to give me pi. So since the period is pi, that's telling me that 1 full sine cycle has to be done by pi, right? There's 1 full sine cycle in pi here. So I know that my sine curve is going to start at 0 and end in pi. All right, so that's one thing to note. I also know there's an amplitude of 4. All right, so I have to consider those 2 factors when completing this graph. So here goes. I'm going to draw 1 point right here at 0, 20. Okay, that's where I'm starting at my midline. And I'm going to be going up 4 units. So that's at 24, which is right around here. I'm going to go back to my midline. And then I'm going to go down 4 units to my minimum value, which is about 16, which is right here. And then I'm going to go back up to my midline. All right, notice I finished my 1 cycle in pi, so I did good. All right, I'm going to do it one more time just to finish this up. I'm going to go up to the max at 24, go back to my midline, go down to my min at 16, and then go back to my midline. Once I have that, I can go ahead and draw the actual sine curve, which looks a little bit like this. Okay, now to triple check to make sure that we're absolutely correct, there was also some other information about Q, right? And so let's just see if what we did matches up with this information about Q. All right, it's telling us there is a vertical intercept at 20. Definitely a vertical intercept at 20, right? We can see that right here. So that worked out. There was no horizontal intercepts. There is a point pi over 2, 20 on the graph. Definitely I see pi over 2, 20 on the graph. So we are a check over there. The amplitude is 4. We definitely have that. And our midline is at y equals 20. Check. Our period is also pi. So this is our function Q. The equation for our function Q is 4 sine 2 theta plus 20. And our graph looks like what's on the screen. All right, so we're going to work on one more task right now. This time, we're actually going to be looking at 2 different functions on a graph, function f and function g, and we're going to have to figure out the transformations. We're going to have to figure out the equations for their transformations. So let's see what that looks like. All right, here you go. So you will notice here, you have a graph of f of x, okay, graph of f of x. In this case, it is cosine x, and the graph of g. All right, the graph of g is on top. It's this one right here. Now, g is a transformation. Let's move this. G is a transformation of f. Okay, so g is a transformation of f. Our task here is to identify a transformation that takes f to g and to write the equation for g in terms of f matching the transformation. So your job right now is to see if you can figure out a transformation that takes f to g and write the equation for g in terms of f. And you're going to try and do this twice, right? So you'll notice here, it's telling you to identify a transformation. And then in here, in step 2, it's asking you to identify at least one other transformation. So again, same as before, pause the video for as long as you need and see if you can come up with 2 different transformations that take f to g and also write their equations for g in terms of f matching the transformation. When you think you have them, unpause and we will review. All right, so when you're trying to figure out how to write an equation for g in terms of f, you do want to figure out what the transformation is, right? What's happening here. So if I just go ahead and look at f and compare it with g, there's a couple of different things I notice, right? The first thing is we're being told that f of x is a cosine curve. So I know that my starting point is at 0, 1 here. And I can tell that I have a max at 1 and I have a min at -1 down here, right? Pi, -1. So right now that's immediately telling me that I know I have a midline of 0, right? And I know that because it's my, regular old cosine x curve. When I compare it to g, what do I notice? Well, I notice in g, it has a midline at 3. So one thing that's happening, right, is that my cosine graph, my f of x function graph, is getting translated up by 3 units. I also notice that there is a stretch horizontally, right? I also notice that there is a stretch horizontally because when I look at my function f, I can tell, again, this is my cosine graph, I can tell that the period is 2 pi. One cycle finishes in 2 pi. But if I look at my g function, it's happening in a lot less than 2 pi, right? It's happening in pi. So I can tell that my period in g is actually pi. Another thing I notice is that this function g, it's being translated. Technically, it could be translated to the left and it could be translated to the right. I'm going to actually go ahead and focus on this idea that it's been translated to the right. So I'm going to say that's where my cosine graph is going to start for function g. So I can tell that my function g has been translated, right? It's been translated to the right by pi over 4. I can tell that there is a horizontal stretch by a factor of 1/2. You can also tell that it has been vertically stretched by a factor of 2. Now, why is that? Well, if I look at my function f, I notice that my amplitude is 1, right? The distance from the midline to the max and the distance from the midline to the min is 1. But in my function g, my amplitude is going to be 2, right? Here's my midline, and I can tell that the distance from my midline to my max in g is 2, and the same with my distance from my midline to my minimum, okay? So there's a stretch that's happening vertically by a factor of 2. And I also notice what we mentioned before, that it's being translated up by 3. So how do we write this? Well, one way to do it is as follows. G of x is equal to 2f, okay? That 2 is indicating that vertical stretch by a factor of 2, okay? 2, parentheses, the second 2, that's helping us remember that it's being stretched horizontally by a factor of 1/2. X minus pi over 4. Now, why minus pi over 4? Because our graph for g, it's being translated to the right pi over 4. Close parentheses, and then plus 3. Why plus 3? Because it's being translated up by 3. Now, you may have also written this. You may have also written it in this way. You may have also written as 2f parentheses 2x minus pi over 2 minus 3. I'm sorry, plus 3. And that's correct too, right? They're both going to result in the exact same graph. The reason for this is because that second g of x graph, or the second g of x equation, that's what happens if you use the distributive property, right? The value of the expression doesn't change, just the look. Okay, one more way that you can write the equation. There's many, many ways, but one other way you might write the equation is g of x is equal to negative 2f, 2x plus pi over 2 plus 3. Okay, now how would you describe this transformation? I'm going to erase this information on the graph so we can see it a little bit better. Okay, how did I come up with this second equation? Well, if I look at f and I compare it with g, I notice that the graph of f, based on this second equation right here, the graph of f is being translated left pi over 2, right? In that first one, we were looking at a translation to the right pi over 4. Here we notice that it's going to be translating left pi over 2. It's being stretched horizontally by a factor of 1/2, so that's staying the same. It's being stretched vertically by a factor of 2. That's also staying the same. It's being translated up by 3. That's also staying the same. But notice that it's being reflected. It's getting reflected over the x-axis because I put that negative in front of the 2, right? So the major two things here that are changing is the fact that now we're looking at a cosine graph that's been reflected over the x-axis. And so really, where's my starting point right here? Well, this was my starting point. I'll just kind of circle that right there. So I'm noticing that it's getting translated to the left, technically by pi over 4, but the way I wrote it is really using the distributive property. That's why we wrote pi over 2. So that's the big difference. And also this reflection over the x-axis. Okay, so what did we do today? We looked at a function and we're given information about a transformation, right? We looked at this function right over here. We were given this function p. We were given information about the transformation to help us graph function q and also come up with an equation. And then after we did that, we looked at two functions, one being our function f and one being our transformation of f. And we figured out, first of all, what the transformations, what was happening, and also how to write the equation for our new graph g, which was the transformation of f.